Hey, this is Manav Misra. I'm the JavaScript instructor over at Claim Academy. And in this presentation, we're going to introduce the basics of two of the most important software engineering tools currently in use, Git and GitHub. We'll talk about what Git is, a version control system, what repositories are. We'll also introduce some basic Git commands. Right after that part, we're going to break out of the slides and do a little bit of hands-on. And I will ask you to follow along, and I will introduce you to a couple of things you'll probably need to install to follow along. After that, we'll look at GitHub. I'll ask you to create an account on GitHub to continue following along. And then we will talk a little bit about branching. And those are some of the... So what is Git? Well, it's a version control system. Here's sort of the textbook definition. As the name implies, when we build software, websites, web apps, a lot of times we have to keep track of multiple versions, especially when we're working on a team-based environment. That means that, version 1 is just like the basic working version. Then we may have a couple of other versions that have experimental features, and so on and so forth. So especially working on large enterprise-grade apps as part of a software engineering team, we've got to have a consistent system to keep track of the versions. But before we go any further with this, let's think about what if I didn't have Git, or maybe what if we didn't have Git? Well, this takes me back to the year 2013, where I had no idea about Git. I was just experimenting and trying to help the city of Columbia build a project as part of an unguided internship, so to speak. And since I didn't really have any clue what was going on, I had to really try to work incrementally. Since I didn't know about Git, this is what I had to do to control my version. I made version 1 of my project, and then I made version 2 of my project. Let's say I had 2 parts of it working. Oh, great. Now, I don't want to lose any work, and I don't want to break anything. Let me make another folder. Here comes version 3, version 4, version 5. I actually got up to version 30 on this one. And during the course of that, I actually had a couple of experimental things I was trying out. Maybe they'll work, maybe they won't. Not only that, but what ended up happening is sometimes I'd be on version 10, and then I would realize that, oh, this change I made to the code here, since I didn't really know what I was doing, I didn't have like a Claim Academy or something to walk me through and train me properly. So I ended up having to roll back a couple of versions. There was a lot of copying and pasting and trying to manually put the code together. So when I finally heard about Git, I really got Git because I essentially was doing all of that manually. And you might be wondering, what about cloud services? Where do those fit in? You've got Dropbox and OneBox, Google Drive, so on and so forth. And those are great for individual documents. I think they do have some ways where you can roll back to different versions. But what they actually lack is there's no good way to label, track, and restore specific line-by-line changes across multiple groups of files. We don't have a good way to label those, capture those changes. So it's great for just single documents, but not so much for entire code repositories or collections of files that we need to track, not only for an individual user, but across an entire development team. And that is exactly what Git does for us. So Git's a distributed version control system. There are some other alternatives that used to be in play before Git became so prevalent, where it was more like a central server. And so all of the different users or team members would sort of log into it, and they would change a little bit of code and then have to write it back. And it was a little bit more of a hassle. So more specifically, it's not the only version control system, but it is at least one of the only distributed version control systems. So where every person on the team can still basically work independently, then there are certain procedures that we can do to merge all of the code together and keep track of everything and keep everything organized. So Git is the most used version control system, distributed or centralized, either way. And I was a little bit surprised about the statistic, but it turns out only 70% of developers use Git. I'm not sure. I should have gotten a source for that, but Based on just some Google searches, I came across that number. I just thought it would be higher, like 80, maybe even 90%. But overall, there are several benefits for developers, and we're just going to scratch the surface on a few of those in just a little bit. So we need to learn just a couple of terms here. Repositories. So you might be familiar with files and folders, also known as directories on your computer. Like in your home directory, you probably have like documents, pictures, videos, things like that. Those are all folders or directories. A repository or a Git project is an enhanced directory. In other words, we specifically tell Git that we want Git to track all of the changes to a particular directory line by line. And that's the difference between a repository and a directory. So we can have all kinds of directories, but sometimes, especially when it comes to a directory of code or a project directory, we want to make it a repository. So it includes not only all of the files in the directory, but a logged history of all of the line-by-line changes to the files. It's really an amazing tool, actually. Let's talk about a few basic Git commands, and then we'll get a little bit of hands-on. So in order to change a regular, boring old directory, if you will, to a Git directory, we use this first command here, git init. And as the name implies, it initializes the Git repo. By the way, all of these commands are entered through the terminal or command line interface. So as an added bonus, we're going to be introduced to how to use the terminal if you haven't done that before. We can initialize with git init, but a lot of times we're not starting with just a regular old directory. We actually are starting with some sort of a base repository that maybe like a lead dev on a team has created, or some sort of a guide. We're not just starting off with bare bones, like nothing in it. So in that case, a lot of times we're cloning. We do git clone. And that is a fancy word for essentially downloading a repo. And we'll look at that after we get started with GitHub a little bit later. As we're working, we're going to want to tell Git when we have finished a certain part of the project or a certain task, we want to tell Git that, hey, we are thinking about grabbing these files and getting a snapshot of these files. And we tell Git that by saying git add. Takes a snapshot of those changes, and the term in Git world is staging the changes. Okay, so they're not committed, but they are staged. Sort of like a rough draft where, yeah, it looks like these are the changes we want to take a snapshot of. We're not fully committed there, but once we are, then we just say git commit, and it takes a final snapshot and completes the tracking process for that particular task. And what we'll do at that time is we'll actually add a message to that. For example, if we're working on a website and we just finished, say, the navigation menu, then we might add all of the files that are involved with the navigation menu. We'll commit them and we'll label it or attach a message that says add navigation menu, something like that. Git status is a great one. That one is used pretty much all the time. So when we're training, when I'm training my students on Git, then I make them use git status quite a bit, especially early on, so they can really, after doing every single git command, they do a git status, so they can see what actually happened. And then git branch and git merge, those are a little bit more intermediate things, and we'll take a quick look at those. But the previous commands, including git status, are the most commonly used ones. This is the part where we're going to break out of the slides. We're going to do a little bit of hands-on. I'm going to ask you to bear with me and set up just a couple of things. I'm going to show you what that is. Head over to gitscm.com, so you can probably just Google search that, and get over to their downloads. And I'm on a Mac here, so it's going to say download for Mac. You'll actually be taken to this screen right here, and it'll say download for Windows or download for Mac. So if you're on Windows, just click that button, download it, install it. Pretty much all of the default things are just fine. In the actual course, where we get a little bit more exacting and in more detail, we do tweak a few of the settings. But I think for what we're trying to do here, which is the basics, just download it. If you're on Mac, though, there's a couple of more steps involved. So if you click here, it'll tell you need to install Homebrew if you don't already have it. So when you click Homebrew, it gives you this big, scary looking command. It's not a big deal. This is where you're going to get your feet wet with the terminal. So you'll come over to this screen and it'll ask you to copy. You're going to paste this in your Mac OS terminal. Make sure you grab this entire line all the way to this quotation mark, including the slash, and Command C that to copy it. And then head on over to your terminal by hitting Command Space. And if you type in terminal, it'll open up a terminal that looks like this, right? So when you open your terminal, make sure you see this tilde. Just to make sure, you can go ahead and hit CD, and that'll take you to your home directory. We're going to talk a little bit about these terminal commands as part of this hands-on. So again, if you're on Mac, open up your terminal, hit Command V to paste that in there, and then just hit enter. I've already gotten this installed, so I'm not going to run it again, but you can just go through and it walks you through. Just accept all the defaults, answer yes, hit enter, and you'll get Homebrew installed, which is an unbelievable, very powerful package manager for Mac, and Linux for that matter. Once you've done that, you can go back to this place and now just copy and paste this command. Do not grab the $, just grab this one. Okay, so you would grab that command, you would head over to your terminal, you would paste that in and hit enter, and then it would install Git. And if you are on Windows, like I said, you already downloaded Git Bash, you're good to go. Here's how you can check to make sure you've got everything set up. First things first, exit out of your terminal and close it out completely. I should let you know, if you're on Windows, tap your Windows key. Once you've installed Git Bash, tap your Windows key and then search for Git Bash. And then then it'll open up Git Bash, and that will look a little bit different. It'll be a black screen, but that's okay. The point is you'll have a terminal. And then so open your terminal back up or open Git Bash. So remember, hit your Windows key and type Git Bash, and then you can do Git -- version. At that point, you should see something like this right here. It may not be the exact number, that's okay, but as long as you don't get an error, you've done great. Last thing to set up is head on back over to your browser. Head on over to Visual Studio Code. That is code.visualstudio.com. Make sure it is this blue icon or not a purple icon. There's a Visual Studio IDE. We don't want that. So all you got to do is download, install, and you are good to go. All right, so moving on now. We're ready to rumble. Let's go ahead and start a project, so to speak, right? So let's at least simulate how this stuff works and what it does for us. So again, make sure you see a tilde on your screen, just to make sure you can hit CD, and at that point you should see a tilde like that. All right, now I want you to go ahead and make a new directory that's going to be for our project. Here's the terminal command you need for that, mkdir, and then just make a directory like new project or practice project. Now, it is a convention to follow Pascal case like you see here. So you capitalize your first word and your second word, okay? So go ahead and do that. And now you should have that directory ready to go. Make sure you have that space, mkdir, make directory, space, and the name. And then you can change into that project by going new project. Okay, so we'll just leave it here for the time being. Now let's go open up VS Code. On Mac, you can hit Command Space and just type code. And on Windows, you're going to hit that 4-flag window key again and search for code. Either way, it's going to bring up Visual Studio Code. If you install that correctly, go ahead and open VS Code up. So when you open up VS Code, you might see a welcome screen, and that's fine. You can hit Control W or Command W to close that out. Now, I want you to open up that project we just started. So go to File, Open, or you can hit Command O or Control O, and you'll find that project. It's going to be in your home directory, right? So if I go, let me go ahead and head all the way up to my home directory. So if I'm here on my Mac hard drive, and I click on this icon, I go to Users, and it's kind of similar on Windows. So you go to your username, mine's Codefinity, and you look for that project, which should be just here in your home directory, like where you have your documents, pictures, movies. There's that new project. So open that up. Okay, so we're going to create a new file with Command N or Control N. So I'm going to hit Command N. And we have this file. We already have it open. And we're just going to type some quote-unquote code, right? this is some working code in our file. Whatever you want to put. You can even misspell stuff. Doesn't matter. It's just a text file. So go ahead and save that. File save or Command S, Control S. And let's give it a name such as practice.txt. Okay, so I've named my file practice.txt. And we will save that. Okay, so we just started our project. We got everything set up. And now we need to get Git involved. Head on back to your terminal. So you should be in this new project directory. Let's clear the screen. You just type clear. And let's initialize a Git repository. Now again, this is just a regular, plain old, boring directory. We can actually see what's in here by typing ls, and as we expect, there's a practice.txt. Let's turn this directory into a repository. Remember how you would do that? You got to type git init. That's git init to initialize this, and there you go. You'll notice that your prompt will probably change. It'll say something like master. If it doesn't, it's not a big deal. Like I said, there are a few details and tweaks that we make in the class to our terminals to really maximize them. But most likely, it's going to say something like master. But the most important thing is it should say that if you did git init. Now that we have this initialized as a Git repository, we can say git status. No commits yet. Makes sense. And it says we're on branch master. And we're going to stay on branch master for the most part. Master is the default name for your main or canonical timeline. Now, when you get into a more advanced project, there may be times when you want to experiment something, right? You have your master stuff working, but you want to create a new branch that you can experiment with some new feature. Maybe it works, maybe it doesn't. And then if it works, you can merge it back into the master branch. So it's a really nice way, branching. It's a nice way to create alternative timelines, actually. But we'll come to that. We'll play with branches a little bit. Right now, we can see that there's an untracked file, and Git is very useful. It tells us right here what we need to do to include this file, to put it on the staging area. So we're going to say git add practice.txt, and then do a git status. And you'll see that it's in green. So this is the crux of using Git. Again, these are the commands that we use. Here's another terminal command you can use. You can type history, and it'll show you the last few commands that you did. So remember, we created a project, changed directory in there, cleared the screen, listed the files. We initialized our directory as a Git repo. We checked the status of our project. We added practice.txt. And then we checked the status of our project again. And if you recall, it said that changes were there and staged to be committed. So they haven't been committed yet, so we're going to try that now. Fair warning, you're going to get an error on this part, and that's okay. I'm not going to get an error because I've already set this up, and I'm going to show you exactly how to resolve this, and then you won't get that problem anymore. But we're going to say git commit -m. Make sure that you don't type git commit and enter, otherwise you'll kind of end up in a bad area. You'll probably have to close out your terminal and come back in. So make sure you say git commit -m and then use these quotation marks. And we're just going to label, we're going to add a message about this commit. And we're just going to say initial commit. That's good enough for our message here. Now, when you press enter, you will not see this display. Git will probably yell at you because it wants to know who you are. We're going to take care of that right now. What you need to do is go back to your browser and head on over to github.com. Head on over to github.com. And we're going to talk more about what GitHub is in just a little bit, but of course, I've already got an account. Let me see. Maybe I can log out. Yeah, if I click sign out, then you'll come to a screen like this, and you'll want to pick a username, email, password, sign up for GitHub. It's just that simple. And then you might as well go ahead and sign in. So pause the video, get yourself signed up for GitHub. It does have a couple of verifications. So you definitely want to be on GitHub. So go ahead and create that GitHub account. When you've finished with that, come back to your terminal. And it actually, if you look at your error message, it tells you exactly what you need to do. But I'm going to show you right here in our notes from class. I'll show you which part you need to actually do here. So what you're going to need to do, and if you look in the error message, it has this exact same thing. You're going to need to type this into your terminal. Git config --global user.name, and inside of quotes, put obviously your first name and last name, and then do the same type of thing with user.email. Make sure that this email is the same one you use to sign up for GitHub. So pause the video, go ahead and take care of that. So now, when you do Git Commit, you can go ahead and type that message again, or let me show you a little shortcut. If you hit up arrow a couple of times, you can get back to all the commands you already used. So make sure that you get this Git Commit done after you've done the Git config stuff that I just showed you, and then you will have made your first commit. You can make sure that it went through by typing git status, nothing to commit, working tree is clean. And there is your overall Git process. Now, if you take out the part where you had to sign up for GitHub, because that's a one-time thing, and if you take out the part where you had to configure your username and your email address, because that's also a one-time thing, it really wasn't a whole lot of work there. We initialized our repo, we did a status, we added, we committed, and we can keep doing statuses. Now, how do we actually see the history of our project? We do git log, and here is a time-stamped history from the author, the timing, and the message, and those changes are committed. Okay, let's keep going. Let's look back in VS Code, and let's make a new change to our file. This is another change. Just put some stuff in there. Make sure you save it with Command S or Control S. Now, what do you think we should type to get the status of our project? Git status. Oh, and looks like changes not staged for commit because we just modified this file again. What's the next thing that we should add? Let's do git add. And you can actually hit tab to autocomplete that file name, by the way. Do a git status. There we go. We have changes to be committed. They're currently staged. Now, if we wanted to, we could type git restore --stage in the name of the file, and it would pull them off the stage. But we don't need to do that. So we are now going to commit, and we'll just say, it's kind of hard to come up with a message, but add second line of code. We usually, when we write these messages, except for the first initial commit, we usually write these in a specific style, an imperative tense verb, like add, and we don't use periods at the end of it, and that is sort of based on some industry standards and best practices. So we've made a commit here. Let's look at one more thing before we move over to GitHub. So let's come back in here and let's add some more code. This is bad code. It will break our project. And let's pretend we saved it and we thought everything was great and we went through the same things. We said git add practice, git commit -m add bad code that we didn't realize is bad. Okay, and so if we do a git log, we now have 3 commits or snapshots. But uh-oh, we added bad code. What do we do now? And of course, right now we could probably go in our VS Code and undo it. But hopefully you get the idea. Sometimes mistakes happen. They're made, people don't realize it. They've exited out. You can't just always use your undo and rely on that. We do have a great way to turn back time. And this is how we do it. See this log here? They have these crazy looking hashes, very unique identifiers. What you can do is right click and copy that. And then you got to hit Q, by the way, to get out of your log here. You can hit Q. And now what you need to do is say get rebase. I'm sorry, not rebase. Get checkout. And then paste in. So you can right click and paste that weird looking hash. And now notice that we are in, we've rolled back time. And if I look back in my code, look at that. That bad code is gone. So now we can make some fixes and we can go back and do another commit and we'll be good to go. But what we're going to do actually is we're going to go back to the real time. We're going to say get checkout master. And now when we come back in here, the bad code is there. So just to keep things a little bit simplified, we're just going to completely remove this commit like it never happened and restore our project to this place right here. And the way we'll do that is git reset --hard, and we'll paste in that big long hash that you should have copied. There we go. Now, if we do a git log, look at that. It's like that never even happened. We've wiped out history. And if we go back to our code, our bad code is no longer there. Just our good code is there. So that is the essence of Git. Again, we're just doing some simple, silly stuff, but these techniques can really make or break a software development team. Now, the thing is, we've got this on our local computers, but we still don't have it safely tucked away anywhere in the cloud. And this is where GitHub comes in. So assuming that you are logged into GitHub, what you'll want to do is click this plus sign up here in the corner and say New Repository. When you do that, it'll take you to a screen like this, and just give it a name such as Practice Repo. And when we name these repos, we usually just keep it all lowercase and use dashes. You can accept the default. We won't worry about any of this stuff for right now. And it'll eventually take us to a screen like this. It'll only take a couple of seconds. Okay. So what you'll want to do at this point is make sure that you have selected HTTPS. Okay, I'm going to select SSH because I've got a special configuration set up, but you are going to want to make sure you have HTTPS. And at that point, you can click this clipboard right here, and then go back to your terminal and just paste that stuff in. So right-click, paste, and just hit enter. And it'll ask you for your password. And once you've entered that password, you should see a display that looks like this. A lot of stuff happening here. At the end of the day, here's what it means. Go back to that GitHub page, refresh. You can hit F5 or click this icon up here. And here is our work live in the cloud. Click on commits, and there's all of the work that we have done on this project. And that is a brief overview of how Git works and how GitHub works with that. Now that we've actually used GitHub, let's give you a little bit more background on really what that is all about. So Git is just a program that we use in our terminal, whereas GitHub is a cloud-based hosting service for Git repositories. Okay, so there's no direct connection between the two, but it's sort of like if you create a website on your computer, you kind of have to put it up on a special server for people to be able to use it. We could have just kept that repository on our computers. We could have even shared it with somebody by like zipping it up or something and sending it to somebody, but that's still kind of weird. So instead we use a service like GitHub, and we actually just set up a repo on GitHub, and then we use those commands that we pasted in. Just to be clear, we added a remote, and we're not going to go over this too much, but we basically added a connection from our local repo up to the GitHub repo, and then we pushed our changes to the origin, which is supposed to be on GitHub, and we pushed our master branch. So that's what those commands were right there. Let's see, we'll look a little bit more about GitHub. So yeah, there's 24 million developers on GitHub. It's a huge community, and make no mistake, if you're applying for a developer job or a software engineer job, this GitHub is your code portfolio. Just like designers have, you know, graphic portfolios, home builders might have like portfolio pictures or whatever. Everybody's got some type of a way in their profession to sort of showcase their work. Well, GitHub is what we use in the developer community to do that. It's a little bit like social media for developers. So again, it's kind of your code portfolio, and many prospective employers do use GitHub. And this is one of the reasons why, in an effort to maximize the chances for Claim Academy students, we make sure that they have a good understanding of how these tools work. So if you followed along up until now, you're doing an absolutely awesome job. Especially if you're new to all of this stuff, which you probably are. You now have the foundations of a couple of the most important tools for any software engineer. Oh, excuse me, for 70% of software engineers. I still don't get that statistic. But you now have some basic exposure to using the terminal. You understand how we can use Git to keep track of our changes. And you understand how we use GitHub in our projects. The last thing we'll look at is a little bit about branching. And this is a little bit of an intermediate topic, but I'm sure you can get it. Let's see if we can get some branches in here. So up until now, we've done all our work on master, and that's fine. But at this time, we're going to create an experimental branch. We're going to say git checkout -b, and we'll give it a name like experimental. You can see that our terminal here lets us know we are an experimental. Depending on your settings, you may or may not have that. Okay, so now let's go back into VS Code. We don't have to do anything special here. And we're going to enter some experimental code. This is experimental code. Okay? Make sure you save that. Command S or Control S. Do a git status. Do a git add, as we've been doing. Git commit -m. We can say add experimental code. Okay? Do a git status and everything is clean. Now the thing is, we just made that change on an experimental branch. What if we go back to master by doing git checkout master? If we do that, and we do a git log, we'll notice that this still has the same commits that were only on master. Let's look at our code. Our experimental code is not here. And that's what we would expect. This is what branching is in a nutshell. You typically can work on master, but at some point you want to start making some branches to really help organize things. So let's say our experiment was a success. We want to add this feature. It's pretty simple. We say git merge. Actually, let me show you one other thing before we merge it. Let's go back to the experimental. By the way, the first time we typed git checkout -b, and that was to create that experimental branch. Since we've already created it, now we just say git checkout experimental. If you put a -b in here, you would get an error, and it would say, hey, we can't create that branch. So checkout -b, this flag, it's called a flag, means that I want to check out a new branch, whereas git checkout is saying, hey, I think this branch is already there. Go ahead and move me over to that branch. Let's do a git log here. So here we can see in our log that this is included in master, these first two commits, but the head just means where we currently are. This commit right here at such and such time by such and such person with this message is only on the experimental branch. Remember to hit Q to get out of this. And we can go git checkout master, git log. There's our log. Hit Q, git status. Nothing's there. Let's bring over our successful experiment. Git merge and the name of the branch. And there we go. It brought over the changes we made to practice.txt. Let's take a look at our log. And now our log tells us that, hey, up until here, this was master. This was done on experimental, and it was merged to master. And now all of our timelines are in sync. But again, what's really cool about that is if our experiment was a huge disaster, it didn't affect the code that we already wrote that was working. We just don't merge that bad code, and that's it. We can get rid of that branch, go check out a new branch, try something else. So I think that's probably enough, probably even a little bit more than maybe you needed to know as an experiment, or as an introduction rather. So we've looked at branches. we make local changes to a repo without making those changes to the master project. And we just looked at merge, which is primarily how we do things. There is another way to do it, which is a rebase, but that's a little bit advanced. That's something we could mention in the course itself. So that's it. Let's quickly fly through here, make sure we touched upon everything. Git is a version control system. It uses repositories. We change a regular directory into a repository. We learned our most basic Git commands. That was, for example, git status, git add. Oh, I almost forgot. I didn't show you how to actually clone a project. Let's do that one. It'll be really quick, and then it'll be even better if you know that one. So if we come here to GitHub, we can actually, so you can just come to my GitHub page. You can get there by going to GitHub Monov M1990. You can really go to anybody's GitHub page, but when you come to my page, you can just click on any of my code repos. It doesn't really matter. And what you're looking for is this green button that says clone or download. So again, you can come to my page, or you can go to anybody's page on GitHub that has public repositories. Just pick any repo you want. If you want, you can even search a repo, and you can just search for any type of repo that you want. Okay? Well, when you find a repo, you click this green button. Make sure that you're on HTTPS. I'm going to use SSH because I've configured this secure shell, but you'll just want HTTPS. Click that clipboard. Again, I'm going to use SSH for mine. And then come back to your repo. Get out of this repo. We don't want to bring a new repo into an existing repo. We're going to so cd, this is a new terminal command, cd space dot dot will take us up a level. So if you do an ls, you'll see that you're in your home directory with your music, movies, and that kind of thing. And that's what that tilde means. It means you're in a home directory. Now let's clone that repo. We can say git clone, and all you have to do is paste that link in, and it'll say something like this. If you do an ls to list things, you'll notice that it created a new directory for you. And this is typically how we work with Git repositories. It's not very often that we start completely from scratch. So let's cd, change directory into that, and we can see we're already in a Git repo. Okay, we're already in a Git repo. We can say git log, and then it gives us an entire history of that project. So assuming that the project actually has a history, you'll see like a bunch of messages like this. Hit Q to get out of that. And that same listing, you can click where it says commits here on GitHub, and you can see the entire history on GitHub. And you can click on any of these messages, and you can get a view at what was added and what was changed. There's a unified view. I prefer the split view. So I usually click on split, and you get a side-by-side comparison of exactly what was changed. But this is one of the things that I work with my students on, is learning how to track changes and even look at other repositories and see how other people have done things. Assuming that they did a good job with their Git repo, this can be extremely useful. And just think about this in terms of the workplace, right? It means that, if you're a new developer, assuming that your predecessor, did a good job of keeping track of commits and putting clear messages, you can look at the entire project history and get a very good idea of where it is and where things stand. So that's why those commit messages, making good commits, is such an important skill. And it's definitely something that at least some companies will take a great interest in. They'll look at your portfolio and they'll say, let's see how good this person does, how clear they are in communication. So GitHub is like the social media for developers. Okay, now I'm pretty sure we've done quite enough. So going back here, basic Git commands. Again, git status, git add, git commit -m, git log. Hit Q to get out of your log if you need to. And then we learned about GitHub, basically social media for developers. It's something that should be on your resume if you're looking for developer or software engineering jobs. Super important. And then we learned a little bit about branching. So hopefully this makes you appreciate some of the very basic tools that software engineers and developers alike use on a daily basis. And that's it. Again, my name is Manav Misra for Claim Academy.